In today's class, we're looking at examples of our function or mapping. Now, let's see this question. Given that what our y of x equals this, equals y or equals 3x plus 4, it means our f is a function of what? Our y is a function of x. That means f of x equals what? 3x plus 4. So, if our y equals 3x plus 4 and our x is coming from real numbers, x represents what? Our domain. Y represents our what? Our codomain. I forgot to mention in the last class. When I put x and y by themselves, x represents our domain, y represents our codomain. But elements of x represents the pre-image or argument, then elements of y represents the what? Image of what? Of value. Now for this question, our x equals this, our y equals what? X squared. This is small y equals x squared. Then our x is coming from what? Integers. Our y equals what? X squared minus 3 over 2. Our x is coming from what? From natural numbers in this case then. So this should be what? Capital letter x. Now, I'm to find what? The domain, the codomain, and what? The range. Now, to solve questions under this function, when we've gotten our domain, automatically we've gotten our what? Our codomain. Now, the range is now what always give us what? Issues relatively in what? Function or mapping. Now, how do I solve my domain? Solution. For number one question, we have our y equals what? 3x plus 4. How do I find my what? My domain. Now, since x means domain and my x equals what? R, it means my what? It means my domain equals what? R also. So my domain is what? Set of real numbers. So many a times in your question on that function, if you have to find the domain, codomain, and range, your domain will always be given to you in your what? In your question. So since my domain is equals to what? R, my codomain also automatically becomes what? R. Now that remains me to find my what? To find my range. How do I find my range in that case then? Now, since my domain is set of real numbers, it means the elements of my x will also be what? Set of real numbers. Now, in this question, we're not giving what? Arbitrary values of x. So I'm going to pick what? Arbitrary values of what? Of x from minus 3 to what? 2. Those are I taught us in graph. Now, pick arbitrary values of x because x was not giving us any value in this case. Other questions you'll be seeing range. That means you might be seeing something like minus 3 less than or equals to x less than what? 4. In this case, we're giving what? Arbitrary values of x for this question. But in this question, we're not giving what? Arbitrary values of x. But since you know that what? My domain comes from set of real numbers, then my elements of my domain will also be what? Set of real numbers. Now, to get my range is what I'm looking for now. To get my range, I need what? I need values of y. That's the images. I need my images. So to get my images, I need what? Arbitrary values of what? Of x, which I've picked out already in this case. Now, if my x starts from minus 3 to 2, my y becomes what? Pull x to be minus 3, I'm going to have that what? Minus 9 plus 4, that's what? Minus 5. If I put x to be minus 2, that becomes what? Minus 6 plus 4. Okay, that's what? Minus 2. I'm adding 3. So this becomes what? 1, 4, 7, 10. This will be my what? Values of what? Y. Now, to now get your range, since you've gotten what? My images. Check the values of your y. What do they look like? They look like what? They look like integers. They also look like what? Real numbers. Now, if you don't know what integers are, you can also check my videos on whole number. The first video I uploaded. Or the next one. So, since my images looks like what? Integers or what? Real numbers. I can say my range equals to what? Integers or what? Real numbers. But most appropriately, I would have to use what? Real numbers, because I was given this in the question and it satisfies this condition. For number 2 also, we're given what? We're given y equals what? X squared in this case. Y equals what? X squared. And for my y equals x squared, my domain automatically becomes what? Integers, because what? X comes from what? Integers. Also, my codomain becomes also integers. Now for my range also, I need to now get what? Arbitrary values of x. Let's start from minus 2 in this case. Minus 2, minus 1, 0, 1, 2, 3. Let's get my what? My values of y before I can get my what? My range. For values of y, I'm going to have that what? Minus 2 there becomes what? 4. Minus 1 there becomes what? 1, 0, 1, 4, 9. If I add 4 here, that becomes 16. If I add minus 3 here, that becomes what? 9. So if I try any value of x into this function, I will get a what? A positive answer. Now comparing or checking my values of y, what do they look like? They look like integers. They also look like what? Real numbers. Now what kind of integers do they look like? They look like what? Positive integers, or what? Positive what? Real numbers, because we are getting positive and positive alone. So we have what? Positive integers or what? Positive real numbers. The most appropriate one here will become what? Our positive what? Real numbers. Finally, we have for our number 3, to be what? Y equals x squared minus 3 all over what? 2. Okay. What do we have our domain? Our domain there is what? Is natural numbers. Our codomain there is what? Is also natural numbers. Now for our range, what I'm going to have as our range, pick arbitrary values of x. Now in this case, for your natural numbers, they are numbers that include the what? Positive integers without 0. As I'm going to have my what? 1 to positive infinity. They are your counting numbers. So let me pick 1, 2, 3, 4, 5. Stop there. So in which case, let me add. It means for my first value of y, when my x equals 1, I'm going to add that what? 1 minus 3, that's minus 2 over 2, which is minus 1. That's 4 minus 3, that's 1 over 2. 1 over 2. So if I put 3 here, that becomes what? 9 minus 3, that's 6 over 2, which is 3. If I put 4 there, that becomes what? 16 minus 3, that's what? 13 over 2. If I put 5 there, that becomes what? 25 minus 3, that's what? 22 over 2, which is what? 11. Now looking at the values of my y, they look like what? Rational numbers. But looking at it, we have rational numbers, we have what? Integers. That's negative 1, we have positive 11. Those are integers. We have rational numbers here. Now, in this case, I cannot see that my range is equals to a set of natural numbers. Never. It is not equals to natural numbers. But my range will be equals to what? Set of what? Real numbers. Why? Because your real numbers comprises of your what? Your natural numbers. Your integers and your rational numbers. That's your real numbers. It's comprised of your what? Integers and what? Rational numbers. So in this case, what happens? My range becomes what? Set of what? Real numbers.